He has a Master's of Civil Engineering from the University of Minnesota, Master's of Science from TCU, and a Bachelor's in Biology, Geology from St. Thomas. So welcome, Steve McComas.
Thank you, Shelley. Pleasure to be here. Sorry, I'm a little bit late, but I think it worked out okay. You heard some good information from the applicators. Those are the guys that are on the ground treating lakes and things like that. What I do generally is go out and survey the lakes and take a look at the big picture for the lakes. And so that's what I was going to talk about today is some of the components of a lake, how lakes kind of work, how the weeds, well, how this affects the weeds that are growing and the algae, and then everything else, how that interacts with the rest of the lake. Should I just hit some buttons or you
Whatever you want to do, or I can, yeah.
or just go to the next one?
Okay. I'm trying to get it up here on the full screen.
Sure, so we're all familiar with the chain and we have some public access. Here we are. Here's a water quality chart listing kind of where we are in terms of a 10-year average. And what happens is that these ecoregion values are called. Let's see, what time is it? Or I should go about 20 minutes. Ecoregion values, what the heck are those? What happens is that the EPA and others have put together, based on the geology and the soils, they put together regions that are in the state that have similar geology and things. And then the lakes within that region, they look at unimpacted lakes and they get an average concentration for phosphorus and chlorophyll and even the clarity. And so our ecoregion is lakes and forest, no, I'm sorry, the hardwood forest ecoregion, which is different than the Corn Belt ecoregion, which is south of us. So our lake typically on average should be a little bit better because we have more sand. The geology here, we have glacial outwash versus glacial till, for example. So here are the values for the ecoregion lake, for the shallow lakes in the ecoregion. And for the most part, we are probably just barely making it with clarity. That's where you drop the Secchi disc down, take a look at how deep you can see it. And so that is the clarity reading. We're pretty close to where it should be for the ecoregion. However, when we look at the algae, we generally have more algae than an average unimpacted ecoregion lake. And for the phosphorus, it should be less than 60. We have a couple of lakes that are a little bit higher than that. And although Julia actually meets that ecoregion criteria, and we consider to be unimpaired for that parameter. So that's kind of where we're sitting right now. The lakes are a little bit more fertile than average, but probably somewhat typical for what we would call a eutrophic lake, which has a fertility level a little bit above the ecoregion values.
Okay.
Sure.
Well,
So,
there's a boy.
how does this all fit in? What does this all mean? So here's a big old chart with arrows going this way and that way. And what happens is that everything in a lake is connected. So for example, physical chemical factors, which are nutrients and stuff, they affect all these parameters. We go up and down, the benthivor's, the carp, can have an impact on algae, and that can impact zooplankton and fish and even fishermen or anglers. The habitat, aquatic plants, look how they're connected also. And the aquatic plants affect all those different components. How do they kind of work? Here's an example. Anglers can have an impact on algae. And the way that works is that if an angling community puts a lot of pressure on the game fish, bass and like walleyes and northern pike, and the game fish numbers go down, then the omnivores, the small fish, the perch, bluegills, and even minnows, without that predation pressure, the omnivores then increase in number. If the omnivores and the small fish increase, like any stunted panfish, if they increase in numbers, then they'll put a lot of grazing pressure, a lot of predation pressure on the zooplankton. The zooplankton are important because they eat algae. So now all of a sudden the zooplankton numbers go down, and then without that grazing on the algae can go up. That's algae numbers. So anglers can have an impact on algae. Of course, it works the other way too. Algae, too much algae can also go up this chain of events or components, have an impact on those components above it as well. So that's just kind of an overview of some of the interactions. I think I'm gonna look at the habitat component next. And that is, having to do with, aquatic plants. So aquatic plants affect all those different components in the lake. And as a rule of thumb, if we can get 40% coverage of aquatic plants, and for the most part, those are native plants, but we can get 40% coverage, we're correlating that with good water clarity and good water quality. So it's a simple way to test. We can kind of check the lakes right now. I mean, on the whole chain, well, what percent plant cover do we have? And if we're less than 40%, we might try to do some things to increase the distribution of aquatic low-lying plants, but typically we want native plants to be that 40%. And that's important because, again, all plants over here, they affect all these different components as well. Well, what might we expect in 2024 with the different spring we had that's a little bit atypical? Well, these native plants are probably going to be sprouting early. In fact, what we're finding, some of these native plants actually overwintered and they're already up. So they got an early start. Temperature and what they call photo period, that's the length of daylight. You know, as we go into the summer, daylight gets longer and longer. These plants are sensitive to that. They always have, there's those two factors, temperature, water temperature, and then a photo period, daylight. So, right now, temperature was way ahead, was above normal. So that kind of spurred some growth early, but we still got some breaks on there because of photo period. That the plants are also sensitive to that. So they're not gonna be peaking yet for a while. However, in the long run, probably looking at a pretty big year for native plants. Because of the early start, low lake levels. And if we go to the next slide, well, the next slide is some more plants. But it has to talk about the algae component. So that other component, the physical chemical factors, when we have too many nutrients, that's going to increase the algae. It's okay for algae in every lake. Every lake's gonna have algae. It's just we'd prefer to have the good algae, which is single-celled algae, versus kind of the bad, I guess you call it bad algae, which is the blue-green algae. Blue-green algae has some toxic components, but the main thing about blue-green algae or cyanobacteria is that they're long filaments. They have they're colonial, or they have long filaments. The zooplankton can eat it. So they're kind of in their own little niche. And once they get going, there's not much pressure to control the algae. So that's a problem. Another rule of thumb, if your water clarity is less than 3 feet, then you probably have an algae bloom going. And that is especially true in July and August. So we want to take a look in August, where are we? If we have transparency less than 3 feet, we want to be a little bit careful with pets and things going into the lake, because that indicates a bloom condition, an algal bloom condition, with the potential for a cyanobacteria or some toxins. Not every algae bloom, here's what's crazy, not every algae bloom has toxic components. We're not sure why some blue-green, and blue-greens are the only algae that have toxins. We're not sure why some of these strains produce toxins. So not every algae bloom is toxic, but we will, because we don't know, and by the time we get the test results back, it takes a week or so, that algae bloom could be gone. So just as a cautionary rule, when transparency is less than 3 feet, we are a little bit more cautious about pets going into the water, coming out. You know, they lick their fur. That's where they pick up some of their algae too, and they can get pretty sick and even die. Let's try the next one. Well, along with the blue greens, which are an algae, we have another kind of a colonial algae, which is referred to as filamentous algae. And this is stuff you see floating on the surface of the lake typically. But you know what? That filamentous algae starts growing on the bottom. It's a benthic algae. Over winter, it's on the bottom, picks up some nutrients, and then if the light conditions are good, it puts up some gas vacuoles kind of inflate, and it floats up to the surface, and then we end up with that type of a look. Now, though it doesn't look good, the good news is that it's not toxic. It just is aesthetically not very pleasing, but it's a green algae. Almost all this these floating mats of algae, filamentous algae, are in the green algae family, a chlorophyta. And so we'll get that. It has about a 60 to 70 day life cycle. It's kind of like corn. Corn is gonna be coming up, and I'm telling you, it has an 80-day cycle, and at the end of the 80 days, boom, it's done. The filamentous algae is kind of like that too. If we don't do anything to it, its cycle is not quite 80 days, more like a couple months. So if it starts now, are we seeing any floating algae yet in the chain?
I haven't seen it done by us.
Typically, it comes in like in May, it starts.
Yeah.
But if it comes in May or June, it's gonna last 60 days, it'll last for a couple months, then it dies back naturally. Puts out resting cells, and then it has that potential seed source, it's almost like a seed for next year. So filamentous algae doesn't look good, it kind of messy for recreation, but it's not toxic. It's a chlorophyta, it's a green algae.
Okay.
So we can see, and this might be a year for some filaments. I'm starting to see some in some ponds and lakes right now. Sure. So what do we expect for algae in 2024? Well, in the water column itself, and including blue-greens, because we had a light snowpack, we didn't have much runoff this year. And because we didn't have much runoff, we're not bringing in a lot of extra nutrients into the lakes. So I would suspect or be ready to predict that our algae growth this year will be a little bit less than maybe it is compared to even last year, where we had a huge snowpack, huge runoff. And that runoff carries sediments and soils into the lake, and that has nutrients, and that goes into the algae. Right now, with the low watershed loading, low nutrient loading, we should have not as much algae, and probably should have better water clarity. So that's what kind of might be happening here in the algae. Okay, well, what's next? Well, how's that gonna affect fish? Don't forget, fish are up and down here, and all these things impact the small fish and the big fish, the bluegills, crappies, and bass, walleyes. So, because we had late ice on and early ice off, the ice season itself is pretty small, short. And so we probably didn't lose oxygen. So most of these lakes probably didn't winter kill this year. So the fish should have made it through. And I'm not sure how good was ice fishing this year. Everybody go out?
I didn't go out.
Not mine. It's a little bit rough out there. So we had reduced angling pressure. So with reduced predation, fishermen basically are the biggest predator on the lake for fish. So that with reduced fishing pressure, we should have more game fish and even small fish, because winter fishing sometimes can put a little bit of a hit on some of these fish species. And here's what's happening though too. So we might have more fish, but we're gonna have probably more aquatic plants. And the fish are hiding in the plants. That's good habitat for them. And so they're in there, but they're gonna be hard to get maybe for the anglers. All right, so that's fish in 2024. Well, so that's kind of up and down, talking about some of our native species. I think I have a few slides now on the invasive species and some specifically in the Briggs chain. Here's what we know we have right now: the curly leaf milfoil, this golden clam, which is only in about 3 or 4 lakes in the whole state. So good news, bad news, is kind of unique. And then there's carp, common carp. But the good news is, as of right now, as far as we know at this time, we don't have starry stormwort or zebra mussels. So I'm going to talk a little bit about some of those. And the first step, I think, is curly leaf pondweed. In 2023, we had some curly leaf. It's in over 800 lakes in Minnesota. They kind of stopped counting. They don't even list it. It's fairly widespread. It's been here since about the 1890s. But because we had a late ice on, we didn't get ice till what? November, December. That's the longest growing season. This curly leaf is unique from the standpoint it is a winter plant. It's a cold water plant. It starts sprouting in September, October. And without the ice cover, it was growing right until the ice came on. And it doesn't, then it just kind of stalls. It's alive, but it doesn't actively grow. But once the ice goes off, then it picks up and you got more light, and then that cues it to really start growing. So we had late ice on, early ice off. We had a relatively long growing season in the fall, autumn, and now with the early ice off, it's kicking into gear. At first, I thought we'd have a lot more curly leaf this year than last year, but it's not always the case in all the lakes that I'm finding right now. An unexpected result was that because late ice on, early ice off, the native plants didn't all just drop down and senesce like they usually do or die off. So right now, we're finding a lot of native plants are still around and present in the lakes. They might have some suppression on the curly leaf. So curly leaf is certainly abundant in some lakes, but not in all lakes. Where we treated curly leaf last year, we're not finding as much curly leaf this year, so. It's different, every lake is like a fingerprint. And they're all a little bit different, every fingerprint is different, all these lakes are different too, so. Kind of hard to generalize sometimes, but that's what we're thinking about curly leaf. Have we done a curly leaf delineation yet this year? On the chain,
Did we do one?
you
Yeah.
finding some curly leaf to treat?
Yep.
Any idea how many acres?
29 on Briggs, 5 on Julia, nothing on Rush.
Okay, if we go back one slide, was that down a little bit from last year, maybe or close. But, so it didn't take off. We were thinking that in some lakes, they would just go crazy and maybe, have 100 acres, but it looks like we didn't. So with milfoil, milfoil is a little bit different than, curly leaf. Curly leaf will die back normally. It's considered to be like a winter annual. It's fairly unique from that standpoint. Whereas milfoil is a perennial. And milfoil, unfortunately, didn't look like it died back over winter either. So we're seeing some standing milfoil right now. It's still relatively dormant, but the question is it gonna come back to life or is it gonna fall back down? So we have that in Big Elk. It's in over 400 lakes in Minnesota. But that's kind of hard to predict what it's gonna do because we have some competition from the native plants this year.
Okay.
Well, that's one AS. And now the question is, okay, we can control them. We can control them with our herbicides. And there's a variety of herbicides for algicides. When you're killing algae, that's an algicide. And then for the plants, it's a herbicide. So are they safe or not? And that's an ongoing question with a lot of debate going on. And here's some highlights, I guess. Yeah, aquatic herbicides do kill plants, but they're designed to really disrupt, for the most part, photosynthesis. Because humans, we don't photosynthesize, it shouldn't have much of an impact on us, but there's always that possibility. So if you see these warning labels, and it sounds terrible, keep out of reach children, warning. Well, that is for the product at full strength, that's coming out of the bag for the applicators and folks like that. Once it gets in the lake, of course, it's very dilute. And those things don't really hold up for the general population. That's mostly for the applicator. So if we look at the next slide, question is, are aquatic herbicides safe? Well, they've gone through extensive testing. US EPA, you can't apply a herbicide unless it's gone through that certification. And they will only certify it if it's safe for aquatic life, for its unintended species, and also they're looking at human impacts for everything from cancer on up. So EPA, for all the herbicides that are being used in the lakes, the EPA and others have done this risk assessment, and a risk assessment gives you a number, and based on that number, they can decide if it is acceptable or not. So a risk assessment can be quantified. EPA, for every herbicide that's used, they consider it to be an acceptable risk. However, there's also another component to this, and that is uncertainty. There's folks and long-time lake residents who, can say, look, I've had some impact, this herbicide is not good for fish or good for birds or things like that. That's possible. But that uncertainty associated with that herbicide impact has been quantified. So with that aspect of uncertainty, we always say there's always possibly some risk involved. But the risk assessment, which is quantified, says, nope, it's acceptable. But the uncertainty, so we hedge a little bit. And that's something to consider. Are they 100% guaranteed safe? No, they're not. But then there's few things that are. It all has to do probably with the dose. Copper, for example, is a important nutrient for us and for all living things. But at high concentrations, it'll kill algae. And so it's all, as they say, toxicity is all in the dose. So that's just a quick overview on some herbicide information. And the golden clam, which is also its scientific name is a corbicula. The good news is that it probably won't spread very rapidly. It is sensitive to cold water. And if we can get a cold winter here and there, the corbicula or the golden clam, as it's called, will die back. And I don't think that it's gonna be a big threat. Its biggest problem has been down south in southern states where it grows all year long. It's about that size, and that's just the size that'll plug up the intakes of a nuclear power plant. And they suck in water for cooling. And when those clams get it all blocked up, they got a big problem. So that's the biggest problem. Ecologically, they're not too much of a problem. Yeah,
How
question?
big are they here? You said down south they're about this big. How big are they?
They're
here?
both same size.
About the same size.
About 3/4 of an inch, a little bit different, a little bit bigger, almost the same size as the zebra mussel. But they're different than the zebra mussel. They don't attach to anything, but it's a true clam. It's one of a clam can put out its products and male and females, the eggs and sperm, they are in the water column. Typically, for all mussels, for all native mussels, that next stage, they have to find a fish and they attach the fish gills. And then they will mature on those fish gills. And then when they get to a certain size, they drop off the fish gills. But without finding a fish gill, native mussels, they don't survive. Whereas this clam, this is a true clam, they don't need to go through the fish. They go right to the bottom, start growing, develop a shell. So that's why these can proliferate a little bit more likely than our native mussels. That's why you call it a mussel. A mussel is something that has to go through a fish. A clam can bypass that, can bypass the fish. It's the only freshwater clam right now, well, other than zebra mussel. Zebra mussels are misnamed, by the way. It should be zebra clam, because they don't need to go through a fish either. But those are the two things, those two AIS don't have to go through a fish. So they'll be tracking, DNR will probably be tracking the corbicula or the golden clam. So one thing that's nice, as far as we know, based on information at this time, we do not have starry stonewort in the Briggs chain. It's in about 27 lakes right now, and it's increasing a few every year. It's not taking off, but it's something we want to watch because it can be very prolific. Under right conditions, it can cover hundreds of acres. It forms these mats up to a couple feet thick. And it's not a plant, it's a macroalgae. It's a little bit like Cara. In that standpoint. In fact, they're in the same family, closely related, but there's not much to keep this from proliferating. So that's why sometimes we'll survey for starry stonewort. If you can catch it early, right at the public access, kind of coming in off a boat, and then treat it there, we've been able to contain it in a number of lakes without it spreading. In Lake Coronis, which isn't too far from here, that's covering about 800-900 acres. And in other lakes in Wright County, we're not too far from some of those. In fact, Clearwater, I was gonna go to Clearwater today until my car broke down. But they have a small infestation. If you can find it early, keep it under control, you don't have to treat more than probably a couple acres, even a half acre. So Sylvia, some of the other lakes, we're treating a half acre, but you have to keep at it. Otherwise, you can get widespread coverage. So, and zebra mussels, again, they're really not a mussel. But look at this, they can attach to hard surfaces. And so even though, and they're not in Briggs chain at this point. So even though we don't have a lot of wood and rock, they'll look at plants as being a hard surface, and then they can really proliferate and attach those plants with these byssal threads. It's the only freshwater clam or mussel that can do that, and it's basically derived from the marine. It evolved out of the marine system, like a barnacle. with these bissel threads, they can attach to all these plants and get carried around. And now that's why it's actually now in more lakes than, Eurasian milfoil, because that attaches to plants. And so with milfoil, milfoil only spreads from lake to lake if it's on the boat trailer. And milfoil sprig is here and has to go to the next lake and then start there. With zebra mussels, because they'll attach to just about any plant from a lake with zebra mussels could have zebra mussels. And so it's multi-species, so to speak. So that's why it's important that we keep all plants off our boat trailers, especially in lakes with zebra mussels.
They can grow in Briggs if they were introduced in Briggs.
Yes, they can grow in Briggs. But now,
Don't they filter out aren't they sometimes beneficial, like relax, they clean the water up?
can everybody ever hear that question? Could zebra mussels grow in Briggs? And the question is, or the answer is, yes, they could. But it's not optimal conditions for zebra mussel growth, because there's some blue greens in Briggs, and they can't filter the blue greens. And then a follow-up was, well, are they good for the water? Because sometimes they do clear up the water, like in Mille Lacs. Well, in other lakes. And in fact, they do clear up the water, but here's what they're doing. They're so good at filtering out the algae that they deposit the waste products down the bottom. So all those nutrients that were in the water column are now in the bottom. And then what you're generating on the bottom are different communities. You're getting benthic algae and filamentous algae. And I don't think you want that. I don't think you want that type of a look. Even though the clarity increases, the nutrients aren't gone, just that they're transferred from the water column down to the bottom. And then you get the benthic algae and it affects the benthic communities, and eventually it's going to be affecting fish. Yeah, any more questions? We'll have some at the end. Okay, well, so for AIS management, for plants and even the algae, there are some herbicides, algicides. Harvesting is still an option for a bunch of plants that are too abundant. And even around your place, you can remove 2,500 square feet without a permit by hand pulling. And so, that also includes native plants. So if you want to get out there, you can do that on your own without a permit. And then there's also sometimes some sediment amendments, like an alum or something like that. That's for excessive algae control more than anything. All right. Well, so, and speaking of improving lakes, the watershed is still the key. That is, our nutrients coming into the chain are coming in from runoff. They've done that for 8,000–9,000 years. These lakes are old, but the phosphorus gets into a lake from runoff, and it can accumulate. And then you can have some sediments that are rich in phosphorus, and then that is also a factor that feeds into the algae growth. But good watershed practices are always the key, because we're finding not only phosphorus is a problem, but also nitrogen. And that's a new finding came out last month. Is that phosphorus is a limiting factor for algae growth. That means the more phosphorus put in, the more algae grow. However, what they're finding is that nitrogen, a lot of these algal species, including blue greens, can be nitrogen limited for part of the life cycle too. So if we knock the phosphorus way down, we want to make sure that the nitrogen is going down as well. Otherwise, we'll still have algae blooms. But for phosphorus inactivation, there is a handy little tool. The phosphorus in the sediments can be tied up with this product called alum, aluminum sulfate. And I think, is there some work toward that in Briggs right
Yep,
now?
they did a feasibility study last year.
So they're looking at the feasibility and how much it might take, and then what the cost might be. This treatment sits on this product here, aluminum hydroxide, sits on the bottom sediments. And any phosphate that comes up, because that's a negative charged ion, and flock, the aluminum hydroxide is positive, it forms a bond. And so it will keep the phosphate from going up to the water column, which then can go into algae growth. So alum is a tool for phosphorus management from the lake sediments.
And we're also doing a carp study this summer. How many carp are here to see if, because all they would do is break up the alum.
Yes, well, that's a good point, because let's go to the next slide. I'm not sure if I can, but we're coming up on the grand finale, but carb can be a factor too for nutrients, because even if you put down an alum, but you don't control the carb will negate the impacts of the alum sometimes. So it's you gotta you gotta hit a lot of those factors, whack-a-mole. Also, another thing that can be done, is these are for homeowners. What can the lake resident do? Well, there's some things you can do with if your place looks natural and native, it's probably good for the lake, and it's also good for viewing, tracks everything else as well. So you have that power to kind of work with your place and make it, and that could help the lake too. Would one homeowner, doing this natural landscaping, native landscaping, increase or improve the lake? Probably not. So what if 100 would do it? So it's incremental. These projects like this are incremental. Small by themselves, not so effective, but once you look at it, maybe, get a majority, then all of a sudden that turns out to be a pretty good potential project and lake improvement approach. Well, here we are. Oh, by the way, here's the carp down here, benthic boards. Look at this, they can have a direct impact on algae because they're putting nutrients into the system. So fish are down here. And especially carp, mostly carp. So again, the alum would work up here and also in the sediments to affect algae. It reduce algae growth. Then once the algae is down and the transparency increases, you might get more aquatic plants. If you get that 40% rule, 40% level, that's good because then that affects everything else. So that's a kind of a quick overview. If there might be another slide or two left, I'm not sure. Oh, the most important slide. No matter what happens, you can't go wrong. I mean, lakes are fun. So never get disappointed. Anything that goes on in the lake. Because dang it, they're great. And if any more information, give me a call or give me a holler, and I can answer some additional questions as well. Let's go back to the last slide.
This one?
Yes, that one right there. So, well, the boats have changed, the swimming suits have changed. The fun, I think, is still the same.
The motors are a lot bigger now.
Motors are bigger, Well, is there time for a couple questions?
Absolutely, yep.
Any questions? Yes.
How long is an alum application effective?
Well, that is, there's some uncertainty. We're not sure. Sometimes it's good for a year, sometimes it's good for 10 years. There's a lot of variables involved with alum, so I've seen some aspects or some studies where they say it's good for 15 years, it lasts for 3 or 4. Other studies, they put it in alum once and it's good for the next 10 or 12 years. So why is that? Well, because sometimes depending on your algae composition, some of these blue greens actually can translocate, which means they have resting cells, and when the alum doesn't affect them, it doesn't come right off the sediments anyway and into the water column. If that's the case, alum might not be that effective for long term. Also, nitrogen is important. So some lakes already have low nitrogen. But in some lakes where there's higher nitrogen, even if we knock down the phosphorus, we have and we don't do much of the nitrogen, that might also spur some algae growth as well. So we have all these factors. There's wind mixing, there's lake mixing, and like Shelley mentioned, carp can have an impact in that as well. So some lakes, a long time ago, we wanted to apply alum once. We said that's good for 10 or 15 years. And then after that, we said, maybe we better split that dose and do it every 5 years, just to keep things under control. And after that, it was maybe we should do it every 4, then every 3, then every 2. We're down now to some lakes we're doing annual treatment with alum because these lakes can be very resistant to some of this alum application.
Do it.
In the long run. Yeah, question.
If you're gonna do weed pulling, hand pulling, what should you do with the weeds afterwards?
Well, what's nice is that they're about 95% water. So there might be a 2-step process. Get the weeds out of the lake, get them up on shore, let them dry for a couple days. They lose all that water weight, and then put them up and compost them. Because there is organic carbon in there, a little bit of nitrogen, a little bit of phosphorus. What they find is that the nitrogen comes out first. That's very soluble. But these plants are still an organic carbon for mulching and for composting. So you put them right in there, put them in your compost pile, and that should be fine. Yeah, question?
We have what I would consider a seasonal infestation of geese and swans on the lake. And yes.
And some
they-
pelicans too.
They're crapping on the ice and everything else like little chihuahuas. and stuff. What effect does that have on the, healthy, the healthiness of the lake?
Sure. Yeah, can we go back a couple slides to that homeowner slide? Well, that's a good question. That's, no, back,
Where am I going?
oh, right there,
There.
nope, the
There.
Lake Smarts thing there. Also, by the way, the book I wrote, that's the book I wrote on the projects, about 300 projects. But to get back to the goose problem or question, that's a great question. About 20 years ago, Michigan State University did a study. They had their graduate students go around picking up the goose litter. And from a yard or from their quad, and then they analyze it for phosphorus to see, well, okay, could this be a nutrient source for lakes and have an adverse impact on algae growth? And they found that you need a lot of geese. The phosphorus content in there is low and it's mostly organic carbon. So the geese as a nutrient source, you need hundreds of geese per day. They have goose control or goose population days. You need 100 geese per day for like 90 days to start having an impact on the nutrient levels. But one thing geese do, and it's because they're warm blooded, they have fecal coliform. And so I think a bigger problem with a high goose population is the E. coli that they are putting into a lake from that standpoint. And so that's something to be aware of. And how do you control geese? Well, that's a tough one. However, when you have a natural shoreline and you have a native aquatic or native plants both in the near shore and in the upland area there, geese aren't likely to walk through that tall buffer because they're afraid of predators. So that actually can be a way to keep geese off your property too, is that buffer strip of native vegetation. So they're afraid of predators. And otherwise, yep. Here's what. Do we have a minute?
Yeah, you go ahead.
Here's what the problem is. There's 9 subspecies of Canada goose, not Canadian goose, they're Canada goose. 9 subspecies. One of those subspecies a number of years ago kind of mutated to the point where they were not so territorial. Most geese are very territorial with their nesting. And we needed to have hundreds of feet apart from the nest. Well, whatever this mutation was, or adaptation, this one subspecies started nesting, very close to each other, 20, 30 feet. And with that success, that population just exploded. Almost all the Canada geese now in North America, or especially high numbers, are from that one subspecies, where they made that adaptation to be able to nest closer together, producing more offspring, more geese. They fly away. Sometimes when they want to come back to that area, they're kind of imprinted there. So they're tough. I know that I was in Iowa one year and I said, man, you got a lot of geese here. She goes, yeah, they all came from Minnesota. Because we used to translocate geese, we'd capture them and haul them down to, I guess, Iowa. Yeah, thanks a lot. All your geese. So dissuasion is probably the best thing. Yeah, question?
Persuasion. We have we did a shoreline restoration next to, on our left, have flat surface grass going down to the lake. The geese are always over there and never over.
Yep.
There you go.
And one little side note too, they prefer Kentucky bluegrass over our native plant. No, Kentucky bluegrass is not from Kentucky. It's an AIS, it's an invasive species. It keeps from England. Well, it has a lot of succulent phosphorus and everything else, so those geese like Kentucky bluegrass. If you're going to plant some grass, consider fescue, which they don't like as much.
Oh, interesting. Well, I have a question. I posed this to the guys from PLM as well. This came from a lake resident on Briggs. And this is PLM's reply. He sent pictures in, he's got wild celery and filamentous algae, okay? And her reply was, Because wild celery is an excellent wildlife food, it is usually best left alone. Abundant growth during July and August in shallow water may interfere with recreation. Herbicides don't work well to control this plant. Hand pulling or raking sometimes works, though floating uprooted plants often reestablish themselves in shallow water. There isn't any treatment that we can do to alleviate this problem, as the herbicide applications don't work on this vegetation. Also, since it is not an invasive plant, we wouldn't be able to treat this on a larger scale past the 100 feet of your treatment area. The filamentous algae can be treated, but within your treatment area. Algae can be difficult as it floats across the top of the water and can always float in from other areas on the lake. If the algae is present at the time of treatment, it will be taken care of. If it floats in the next day, there isn't anything we can do about it, unfortunately, as our products are contact herbicides and algicides and not preventative type of treatment. Algae also thrives in hot weather with little rain. So the summer of 2023 was prime weather for it to grow in. They wanted your opinion on that, if that was,
You know, that's from a herbicide applicator.
yeah,
Well, I think it's very fair.
okay.
I think, they gave some good information. I mean, they want to promote out, I mean, their business is herbicides, algicides, but that was decent, because I agree with most
You
of
do
that
it?
stuff.
Okay,
What happened is that the last few years, climatic conditions, I'm not sure what those are, but water celery is taken off across the region. And typically it grows in shallow water, only up to about 4 or 5 feet or less. And so it's a near shore area, and then water celery is that plant that looks like seaweed, basically. And it can be it can grow very thick. But the good news is that it is weakly rooted. And that's why come fall, you'll see these rafts of water celery around the lake. Because the coots, when they're staging, they're going in and going for the tubers, because it's good duck food. And so then they're uprooting those. And even wind action can uproot this weakly rooted water celery. So it's a good native plant. It offers a surface for macroinvertebrates, the little aquatic insects and everything else to, the fish will come in and feed on those bugs. And so it has a lot of good benefits, but it can be a recreational nuisance, not an ecological nuisance, but a recreational nuisance. And that's where that hand pulling, raking could probably take that out. Also, by the end of August, or right around August, you'll see these little spirals coming up off that water celery. And that is putting on its seed stalk. So we see water celery, and then toward the end of the summer, you see those little curly cool things coming up off that. That is a seed stalk. At the very end, you'll see a little white thing, that's their seed. So they'll do that, then it's even more of a mess. This is just wrapped up in your crop. So I look at that as being more temporary. I don't look at that as being a long-term real potential problem. Because 20 years ago, it wasn't much of a problem, even 10 years ago. But in the last 4 or 5 years, I've seen more and more water celery. And herbicide applicators don't like it because they don't have a good herbicide to really treat it, to knock it out. And if there is one out there that treats it and kills it, be aware, because that has to be a very powerful herbicide.
Mm.
And I don't think we want to use that on a widespread basis.
Okay. And you said native plants are probably up and good and growing this year, right?
Yeah.
Already. But does that mean the invasive ones are
Not necessarily.
not necessarily?
I was
Okay.
surprised that curlyleaf didn't take off like it did. I mean,
Okay.
I would, they were expecting things like double from last year. We don't have 80 acres of curlyleaf in the chain this year. We have less than, similar to what we had last year. So it didn't really take off. I think the native plants might have had some role in suppressing that.
Oh, good.
However, the Eurasian milfoil also didn't die back over winter. So it might get a jump. Now, the question is, there's always that competition out there, natives and non-natives. Hey, these native plants, don't give them short stick. They're tough as well. They'll sit in battle with any Eurasian milfoil. And a lot of times it is a competition for space, for nutrients. And so we'll see who wins. But the native plants they can hold their own.
Okay.
What do you think of aquasite pellets? You see them advertised all the time.
Yeah.
Do they kill everything or?
Well, those aquasite pellets typically are a 2,4-D herbicide. And 2,4-D is very specific for Eurasian milfoil and for narrow or for broadleaf plants. But it's not gonna do very well. It doesn't have much impact on the stringy pond weeds. And here's why. 2,4-D is a herbicide that treats dicotyledons. It'd be like, an example would be like dandelions are dicots. And 2,4-D, weed be gone, if you look at the label, is all 2,4-D. So that'll kill the dandelion, but not the grass, because the grass are monocots, and which is just a name that has to do with their seed. But grass are monocots, so weed be gone, when you spray it, doesn't kill the grass, but it kills the dandelions. Aquacide is a 2,4-D, it'll kill the dicots, and that is like coontail and milfoil are dicots. But our pondweeds are not, and water celery are not dicots, they're monocots, so aquacide will be somewhat selective, won't kill everything. But it'll ding, the coontail and should knock down the milfoil.
Is that legal, Minnesota?
Yes.
Yes, it is.
You get a permit.
You have to get a permit.
You gotta get a permit. It's one of the few herbicides though that you can apply yourself. You can apply without an applicator's license. Any other herbicide, you need an applicator's license.
Can curly pondweed not be showing up right now, but show up later on in the year?
Yeah.
So it's a separate site.
Well,
Or they're already down there, they're just not.
yes, here's what happens. It puts out these little seed stalks, or I'm sorry, little stems in fall. And then winter comes and then they just stay there. But as soon as the ice goes off, those
Curious?
the turians put out runners, and then you get multiple stalks coming off that runner. So what was one time, 1 plant per square yard, now you have 100 plants per square yard, so they can really proliferate like that. The sprouting of those turians, the seed stalks coming off this turian, which is not a true seed, it will continue for the next 3 or 4 weeks yet. So we can treat it right now. And we'll get good control of what's growing right now, but we have this grows till, July. So we can still get more, sprouting but then it's cut off. The applications for curly are cut off. Applications for herbicide treatments are cut off. And this year it's a little bit earlier than usual because here's what happens. Curly is treated primarily with that dicot or an enmethyl, which is a contact herbicide, which means on contact, hits the leaf surface, it'll kill the plant. And, because it's a monocot, 2,4-D won't affect it. So we have to use a contact herbicide. Well, right now, the native plants typically aren't growing yet. On a normal year, they don't start growing till water temperatures hit about 60 degrees. So if we treat curly early in the year, and it's the only plant growing, then we get some selective control. We're trying to control the AIS and not really ding the natives or harm the natives, so. But the cutoff is in April, end of April now, and we still have all of May and June, so there could be some more curly leaf sprouting. And it wouldn't be a bad herbicide application, it'd just be, that's what curly leaf does. But it stops growing mid-July because the temperature dies back. And then it waits till water temperatures cool again, come fall, it'll start growing.
I was gonna mention, I don't know how many years ago that was, they tested all the outlets and inlets
Oh, yeah.
of the chain for egg runoff.
Mhm.
And the phosphorus level was low
Hmm.
there.
Mhm.
So the highest content is coming from lake properties that are fertilizing.
Yeah.
So, so the best thing to do, in your opinion, is fertilize with the lake water,
Yeah. we can use
with all the
that.
nutrients in it.
Typically our soils have almost enough nutrient. Rarely do they need fertilizer.
Mhm.
We can do soil tests and things like that, and they'll tell you, oh, potassium, this and that. For the most part, these plants don't need many nutrients to really grow. So we don't, in fact, with the fertilizer restriction, we can't get a lot of fertilizer now with high phosphorus. We used to have high phosphorus,
Mhm.
but they found out, hey, our soils, we don't really need a lot of phosphorus. So fertilizers now are low phosphorus, but still they have high nitrogen. So we have phosphorus and nitrogen running off, and lake water would be as good as anything. Most of these plants in lawns are water limited, not nutrient limited. You water a patch of grass, it'll typically grow with enough water, and don't even need.
Okay.
Yeah, question.
If there's a lake that's pretty much all clear, and then you start getting algae on it, where did the algae come from? How does it get there?
Yep, right. That is, that algae typically is growing on the bottom. So algae starts growing on the bottom, and at the end of its growing cycle, including filamentous, at the end of its growing cycle, it will produce these resting cells, cysts, settle down to the bottom. And algae does that too. Almost all algae species have resting cells. And so at the end of their period, at the end of their time, they form a resting cell, sink down to the bottom, and they sit down there until conditions are right again. Until temperatures or sunlight will then activate them and they come back to life. So almost all our algae is coming from the bottom and over winters. So we have green algae right now dominant. The blue greens that'll come in July and August, they're still down there in the bottom. They're in their resting cells right now. But they'll be activated with temperature and light and things like that, then the blue greens come up, and that's why sometimes you say, this lake was crystal clear a week ago, now we get this big algae bloom. Well, algae only replicate about every 7 days. So a lot of that bloom comes from the sediments from the algae in mass, rising off the bottom, coming up, and all of a sudden, boom, we got a big algae. Or they'll start growing there. They just stayed down there alive, but now they're in the bottom of the lake. That algae, it can also have gas vacuoles. They put energy, they put gas in their gas vacuoles, floats them, it's like a float. Boom, all of a sudden they come up to the surface for more light. They grab the phosphorus from the sediments, get filled up with phosphorus, then they go, now we need some light. They bubble up and they, boom, they're at the surface. And that one picture, that algae, a lot of the blue greens at the end of the summer are floating on the top because maximum light. But it all works out. And don't forget, because lakes are fun. Heck, we're not that.
Yep.
It's time to get out to the lake.
Time to be up to the lake.
Anyway, thanks. So.
Yes, thank you, Steve.